The next circuit analysis technique that we are going to see is voltage and current division. First we will see what is voltage division. So whenever there are resistors in series, okay, let us take n number of resistors in series. Now the voltage across the entire branch is given to be V. Then how will you find out the voltage across any particular resistance? Okay, for example, if you take some resistor RK here, okay. Now what is the voltage across this given the resistors and the total voltage across this branch? How will you find that out? So this is given by, you can take the current will be same, which is I. Now what will be the voltage Vk? From Ohm's law we can write Vk is equal to I into Rk, okay, but we want in terms of the total voltage, right? So I you can write as V divided by R equivalent, which is nothing but for a series connection sum of all the resistors into Rk, okay. So the kth voltage, that means the voltage across the kth resistor, is given by Rk divided by sum of all of the resistors into the voltage across the entire branch. So it might seem very simple, but this is going to be very useful whenever you are analyzing the circuits. Okay, so this is nothing but voltage division. Now next is current division. So voltage division comes into picture when there is a series connection. When will current division come into picture? When there is a parallel connection. So here you have n number of resistors, R1, R2 and so on till Rn, and the voltage across them let us take to be V. Now we want to find out what is the current through an kth resistor, Rk. Okay, so Ik we want to find in terms of what? The total current. We know the total current. Now how will this total current be divided? That is the question here, current division, right? So we will take Ik, we can write as using the same Ohm's law, okay? So the voltage across the resistance divided by the resistance value, which is Rk, okay? So now voltage you can write as I into R equivalent divided by Rk. Now this how you can write 1 by Rk divided by 1 by R equivalent into the total current. So we got into this form because it is a parallel connection, and R equivalent we can write easily when it is given as 1 by R equivalent, okay. So what is Ik? This is equal to reciprocal of the resistance of that particular resistance divided by the sum of the reciprocals till 1 by Rn into the total current. So this is the expression for the current division, the current through the kth resistor, okay. Now I want you to see the special case of two resistors in series and parallel, because it is important to remember these expressions. When two resistors are in series, then what will be V1? This is simply equal to that particular value of resistance divided by R1 plus R2 into V, and V2 is equal to R2 divided by R1 plus R2 into V. Now what about two resistors in parallel? This is I1, I2, let us say. The total current is I, okay. Now here you can see that I1 you can write as, this is R1 and this is R2, 1 by R1 by 1 by R1 plus 1 by R2. So if you multiply by R1, R2 in the numerator as well as denominator, what are you going to get? I1 is equal to R2 divided by R1 plus R2, and I2, this is into I, and I2 is equal to R1 divided by R1 plus R2 into the total current. So I just want you to see that the difference. There is voltage division, V1 here is there, the same resistance will be in the numerator. Whereas in parallel connection, the current the current will be divided in proportion to the other resistor R2. Okay, so you can see in proportion. Why I am saying, because V1 by V2 is equal to R1 by R2. So the voltage division is according to the resistors. But here I1 by I2 you will be getting as R2 by R1. That means they are inversely proportional to their resistance. I1 here 1 by R1 is there on the other side. Okay, so this is what I want you to remember, the contrast between this voltage and current. Also, what about the case when all of the resistors, they are equal? Okay, so that means n number of resistors are equal. R1 is equal to R, R2 is equal to R, and so on till Rn is equal to R. Then what will be the voltage across each of them? It is all going to be one and the same. This is Vn. This entire voltage is given by V. Then V1 is equal to V2 is equal to so on till Vn, which is equal to the voltage, total voltage divided by the number of resistors. Okay, V by N. Similarly, when there are equal resistors in parallel, n number of resistors in parallel. So if you are taking I1, I2 and so on till In, the total current is I. Then I1 is equal to I2 is equal to so on till In, which is equal to I by N. So it just means that the voltage will be divided equally when the resistors are equal. Similarly, when resistors are equal in parallel, then currents will also be divided equally. Okay.